Hey everybody, this is Larry. This is me going over day 26 of July's Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord, let me know what you think about today's file. So I'm in sunny San Diego today, and for this week, I suppose. So I'm excited. Hopefully the sound is quieter because I'm not around people as much. But yeah, let me know what you think about today's sound quality. Hopefully it's good. Today's problem is going to be convert sorted array to binary search tree. So I usually solve these live. So if it's a little bit slow, fast forward, do whatever you need to do to kind of, do whatever you need to do to, you know, get to where you need to go. Okay. So yeah, sorting this. Given array, convert it to a height balanced binary search tree. Okay. Okay. Is that really a depth of the subtree every node? Okay. This isn't so it's in a strictly increasing order. I mean that part's not that whatever. I don't know how to think about wanting to do this because this is very silly, right? In that this is literally a textbook problem, and by that I mean literally a problem that you may see in a textbook and just doing it, and doesn't really have I don't know. Yeah, and you may learn this in algorithms class or something like that in college, but beyond that, I don't know. How would I? Hmm, I think the biggest thing is just to do it recursively, and recursively you can think about, and maybe this is a good practice for divide and conquer. Now that I think about it a little bit, because then now what are you trying to do? Well, you basically given a list of nums and you're going to just put the middle in the root and then kind of just recursively construct with the sublist, right? So then the question is, do you have to be careful? And in that you can imagine a case where, well, I'm trying to think, the tricky case is that you have some degenerate case where you keep on putting everything to the left or putting everything to the right, then things are going to be unbalanced at some point. But we can probably play around with that and fix that later. Let's just get the core idea correct, and then we'll play around with the edge cases. I think there are some techniques that I know off my head that can kind of either probabilistically fix it or just I think there are ways to kind of enforce it, but and you can even maybe do some rebalancing. But I think let's not get ahead of ourselves. Let's see if this is a problem before we get started. So anyway, so let's do that. Let's go construct, and then we just take a node, and then the index of left and right, say, and here is that what I want to do? No, that's not what I want to do. What I want to do is just construct left, right, and then I can do something like, okay, if left is equal to right, then we have one node left, so then we just return a new node, a new tree node of value of num sub left, and because num sub left is equal to num sub right, and there's nothing to the left or right, so that should be good according to these definitions. And otherwise, then we just set middle is equal to left plus right, by 2. We know that tree node, or current is equal to tree node of num sub middle. And then now we want left, right? So let's construct the left. Left is equal to left middle, but in something like this, right? So let's actually, just to make this, we can add more if statements, but to make this slightly easier, if left is greater than right, then we just return none. So that means that if this is left is greater than middle minus 1, then we return none. And here we can do current.left is equal to construct that, and current.right is equal to construct middle plus 1 right, inclusive, right? And I think that should be good enough. Return coin at the end, and then maybe just return construct of 0 and n minus 1, where n is equal to the length of nums. I think that's good enough to start off. We'll see if this is good. See if this is Gucci. This looks, I don't know if this is actually, let me take a look to see if that's right. So this is, because now we have to draw it out a little bit. So to the, oh, right. I wish there's like, I feel like there's an interface somewhere where they show you 1, 3, and 3, 1. Is this the right answer? I don't actually even know, because they say that this is 1, 3, but I think this is technically 103. So I think they give us the wrong thing, if I'm correct about this format. And then okay, so 0, 0, negative 10 on the left, 5 on the right, and negative. Okay. Let's just give it a submit. I think this is right on the input. Hopefully this is good. Like I said, the only thing I worry about is that if it becomes too unbalanced, because this has a sort of a, so this has have a left bias, and what I mean by that is that it can it rounds down, right? So you can, in theory, imagine a case where it gets too unbalanced, but I cannot prove it. It's just that my skepticism, right? And now we prove by AC, kind of. It's not exhaustive, and we'll have to figure it out. And I think the only thing that you can tell is that, like, the numbers itself don't matter. It's about a length. And I guess if it's good for, say, 1 to 8 digits or 8 elements, then I'll probably be satisfactory. But yeah, that's what I would test. But, or some powers of 2, or close to powers of 2. So either powers of 2 or powers of 2 minus 1, or something like that. And that would maybe generate these kind of imbalances. Okay. Am I Gucci? Yeah. So this is going to take linear time, even though it is very awkwardly constructed, and it may, you may intuitively think is n log n or maybe log n or something like that. But actually, if you look at it, this get constructed so looking backwards, we do construct a tree node for each number on this. So because of that, this is going to be O of n linear time, because we only construct n tree nodes and we don't really throw away. I mean, minor extra work, but that's going to be constant amount extra work. So yeah. So each element so you can think about this as, I mean, it breaks to be in the pieces, but it breaks to n number of pieces, where n is the number of numbers. So it's going to be linear time, and it's going to be linear space, both in the number of tree nodes and just recursive base stack type thing. So even though you can also say that this is O of h, but h is going to be dominated by n at some point, or for some inputs. But yeah, so linear time, linear space, that's all I have for today. Happy Monday. Hope y'all have a great rest of the week. I'll see you later. And yeah, stay good, stay cool, stay healthy, and to good mental health. I'll see you later. Bye bye.